Tuba hocam, welcome. Good morning. I think it's 8 a.m. there, right?
8:30, yes.
Okay, thank you for sparing your Sunday morning to us. We are very grateful for that. Yesterday, Emre Hoca touched upon the CSS applications on migration studies too, but we are really looking forward to hear your perspective as well. So I'm not going to make it any longer. The stage is yours, Hoca.
Oh, thank you. Thank you very much. So I'm very glad to be here as well. Especially since I've been abroad for quite some time, it's always a great pleasure to reach out to people from my origin and my home country. Besides that, it's also very, very honoring. I got to say that the social scientists and social science students pay more attention to these more computational methods. I could not catch Emre Hoca's presentation yesterday, but I'm pretty familiar with what he's doing. So I do think that you'll see a lot of overlaps in terms of the concerns and how things are done. But what I'm going to today is mostly talking about real applications. So I'm going to frame the topic around the project that I'm currently leading, which is called the Hummingbird Project. In fact, the project is not solely on the CSS applications. We are also working with qualitative methods. So in fact, it is about the mixed method approach to understand human mobility and migration. But today I'm going to specifically discuss several data sources that we are gathering together, which are going to be available after the project, and how we do it, how we develop indicators, how we analyze mobility. The Hummingbird project itself, Hummingbird project itself is an interdisciplinary project where you will see a lot of different disciplines coming together, from data science, computer science, anthropology, and political science, sociology. And we are 16 partners in total and from 10 countries. Why I wanted to keep this slide is not about promoting the project itself, but rather to show that if you are going to work with big data particularly and computational methods, you need data. And these data are mostly held by private companies. So in addition to that, these new data sources and the methods come along with some concerns as ethical issues and as well as societal concerns. So what we did for the Hummingbird project is that we do have several companies on board to work together, not only as a data source, and we have several NGOs because we are working with refugees and migrants. So what we have is that, in addition to our academic partners, where you can see the logos of, we do have an ERIC, like European Research Infrastructure of CESTA, which is the largest social science data archives in Europe. And we do have some companies, as I said, Truxel Technology, GMV Research. In addition to that, we have CHILD, which is a coalition from Italy of the legal support. We have Caritas, we have MPG, Migration Policy Group. So we do also have NGOs. So in terms of geography, we are combining the quantitative and qualitative approaches. I'm going to talk about the quantitative one. And among the quantitative, we are working with analytics, empirical analysis of the also the assessment of alternative data sources. Is how can we use computational methods to develop new indicators that are not possible to assess through traditional methods, or let's say to improve the existing issues with the migration statistics, and then also develop and infer several indicators, but from the qualitative data, because we are conducting ethnographic fieldwork in 6 different countries with the migrants en route, which means we are talking to people who are still on the way, who have not yet reached out to where they're heading to. And combining quantitative and qualitative indicators, of course, the ultimate goal is how can we have a better understanding of future migration? So, as I said, why do we need these new and other data sources? Because if you're not very familiar with the migration studies, in fact, it's pretty straightforward. most of the policies and the understanding and the research on migration, especially international migration, rely on some very well-known, long-lasting administrative data. We are talking about the population censuses, which used to be more in a survey nature, but since the last decade, we are mostly working with the population register data. And when we have the censuses, we use this data for understanding the flows. So how many people come in from which area, how many people go out. So the flows are the mobility, so the number of people on the move. But we can also talk about migration stocks. Migration stocks refer to how many migrants there are in a specifically defined geographical area. So administrative sources support these censuses because we are talking about social security databases, population registers, it could be health registers. So it is the administrative data that are gathered by the governments and the public authorities. But these are mostly about, as I said, the flows, like how many people come in, come out, how many there are. But we would like to usually know more about the well-being of the migrants too. Migrant integration has been on top of the political and social agendas for long, and to understand how migrants are doing, in addition to population and administrative sources, we are using large-scale surveys. These are mostly, especially for the European case, these are the policy frameworks. So we are talking about EU Silk, like so. This is the social indicators for the living conditions. We have the labor force survey. You have even more like European quality of life survey. We have the working conditions survey, and we also have some global efforts, like say the Gallup, the World Poll. So if we have so many, yes.
Sorry to cut you. Are you proceeding the slides, or
yes?
We are only seeing the first one right now.
Yes.
We can't see the next slide.
So wait. Let me stop share and try it again. Okay. Now, can you see it?
Yes.
Okay. So, Hummingbird project, the countries, and the data sources. So, then why do we need new methods? Why do we need the CSS? Because among the migration measures, we are measuring immigration, incoming migration, emigration, outgoing migration, which is inflows, outflows. We use granted visas. We have the residence permits, which are usually used for the drivers, like the reasons. I mean, do people come to that country to work, to study, as a family member, or for humanitarian reasons? And for the migrant stocks, like assume that we are calculating the number of migrants in Turkey. In fact, we are working with only two indicators. We check the country of birth and we check the country of nationality. However, these two have some challenges with the new dynamics of migration, because we do know that when we consider different data sources, there are 5 significant gaps in the migration statistics, and computational social science methods and big data particularly can help us at least to show if these alternative approaches can be used for compensating these gaps. Definitions and typologies is the first thing. I'll very briefly talk about it. When we say definition and typology, we are talking about who is a migrant and what type of migration and migrants there are. So assume that as a student, as a fresh graduate, you decided to go for a master's degree to the Netherlands. And then after your master's degree, you said, oh, maybe I should go for a PhD. And then you become a PhD. You're still keeping your student and educational purposes, migrants status. And then you meet someone, you get married, you don't have a job, you become a family dependent. And then you found a job, you changed your status, you became an economic migrant. However, the register statistics cannot really capture the changes in your status. In addition to that, when you are talking about, for instance, a refugee, if you look at the Eurostat data, check how many refugees are there in Turkey, you would see that around 10K. It is because by legislation, Syrian migrants are not defined as refugees, but they are defined as guests. So the definitions and typologies matter a lot on the national legislations, but also international compatibility. Then the drivers, as I gave the example, it could be mixed. You would like to go to another country for many reasons. It could be a temporary, it could be a permanent one. Demography, gender, hidden populations. Especially within EU, it is more difficult to track who goes where. But in addition to that, we are talking about disaggregated data. Very basically, for the refugees, no education information is kept. If you go, you can find it sex segregated one. Geography and space, it's about what's really happening between countries when we are talking about international migration. What I'm saying is that if you check the numbers, even in the Western Europe, like emigration, the outgoing migration from Germany, and then if you check it by the border countries, immigration, you're going to see that there are mismatch. And the temporality is the main issue. I got to say that can big data help us a lot, because the data statistics that you have today in December 2021 refer to 2019. So we are really missing an important period of time. So what type of digital traces then we can use to study migration and human mobility? In fact, there are plenty of those, but I'm going to specifically focus on 3 of them. The first one is the internet derived. So these can be social media, your Google searches, online interactions, as well as the mobile devices, wearable technology, Internet of Things. So whatever you have that has a Wi-Fi or 4G, 5G, or 3G connection, you can be connected to the internet, and the internet is a hub where you can really gather several information. And the second part is the tracking data. So the tracking data, this could include the mobile phone as well, because we are talking about monitoring movements through some devices. And these devices can be the GPS on your mobile, on your wearable, on your car, as well as the geolocation data, because the social media data can also have the geocoded information. And that could be a traffic or transport sensor data. It could be the CCTV, like the security cameras all around. So besides the internet drive, we can also track the mobility. And thirdly, which is a more broader one, we can work with the satellite and aerial imagery. So now we are talking about remote sensing and Earth observation, which means the pictures of the Earth at different definitions. This could come from an internet provider like Google Earth, but we can talk about an American source like the Landsat, or we can be talking about some satellites by the European Union like Sentinel-1, 2, but it could be infrared, it could be radar mapping. I'm not going into even the military applications. So basically, we are talking about internet source, tracking data, and the satellite one. Before talking about the real applications, I would like to get your attention to a very important questions like, how much we can expect from new data when we are really dealing with the old questions. Here, I got to say that the data-driven and theory-driven approach comparison makes a lot of sense, because when we are talking about pattern recognition, data mining, text mining, which are based on finding out systematic and rooted patterns and similarities, it is mostly data-driven, which means we are trying to make sense of the existing data. However, we do know that in most of the social science disciplines, we are talking about a theory-driven approach, which means we need a conceptual framework to have our questions, regardless of inductive or deductive techniques. We have a conceptual framework where the theories guide us in terms of our expectations or our questions. So it is not that easy to combine this theory-driven approach with the data-driven approach, because we are talking about use of something that depends on what data says, but it doesn't talk a lot about how data is collected, which type of questions that data can answer, but more importantly, it has its own ethical and social issues. So the main question is, how can we make use of these new data sources in a more ethical and socially responsible way? So referring to your, this is a medical article, but I do like it a lot because it gives you a very nice illustration of cycle of knowledge, because you do know that in general research methods, either qualitative or quantitative, we have different circles. You start with the topic, then you have a research question, and then you either go through maybe a grounded theory, or you might really go for an empirical study, either qualitative and quantitative again. So here, with being ideas and data, we do have the hypothesis, we have the analysis, and we have the deduction. But the synthesis and induction can be between data and ideas. So it's really important that hypothesis-led studies are, let's put it this way, the data, this new approaches are not an alternative. So we are looking for ways how we can integrate the computational science approach into the social science approaches that we already have. So I I mentioned that we are talking about different types of data, but it's important to give you the first first sight of the big data landscape, because it is not something that all the social scientists are very familiar with. Because on one hand, we are talking about the data sources where we can get data, but on the other hand, how we are going to analyze it, how we are going to manage the data, how we are going to analyze it. So I'm not going to talk about all of them, but a couple of them are pretty important in terms of the analysis part. So I'll start with the analytics and visualization on the right corner up, because you do have several programs and software and programming, let's say, languages that help you to illustrate our data, as well as making the basic analytics. But when I say analytics here, it's not really like the open code systems. This is more like using a package to analyze your data. And then if we look at the very bottom about the technologies like Hadoop and MLR, we are talking about mostly, like the new programming languages. But I gotta say that although R is not here, in fact, R has a very important space in analyzing the different types of big data. So what can big data bring us to improve our understanding of migration mobility? It, it brings the information on simultaneous interactions that we do not get through the register data. We have collective mobility behaviors. It is in real time, that's the most important part, and it's on global scale, so we are not restricted with the geography. So let's see what we have done so far in the Hummingbird project, particularly with these new data sources. So if you remember what we do, how we measure the mobility, like migrant stocks is one of them. Like, can we estimate the number of migrants of definition that we prefer at this moment? So we use Twitter and Facebook marketing API data. So what we do is we analyze, or let's say we check the effect of the social networks in attracting migrants and how people decide where to go. But so we also tried similar models, a gravity model, and then we also analyze like the policies and political changes, especially for instance, the highly skilled migration. I'll give you a couple of examples of what we have done so far. We started with the Facebook data. This is an API data. And of course, even if we are working with big data when it is about migration, it's really important to combine the data sources with others, because not only for the robustness, but also to make meaning of what we are doing. So what we did, we are working with several data sources, humanitarian data exchange and Facebook data for good. We use the Facebook Connectivity Index. We had UN data for the migration flows. Then we had Eurostat data for the European statistics. We have this UNDESA, we have the World Bank. So we used several data sources to complement the existing missings in the data. But the main idea is, let's see and compare to develop indicators for the Facebook data and the regular statistics, traditional ones. So our data set is between 2018 and 20. We are working with bilateral migration flows, and it's not zero, so it's country to country. We do have 232 kind of different countries. It's a huge matrix, as you might guess. In fact, we are talking about more than 40,000 records on EU level and almost 20,000 on the world level. So this is a dyadic analysis. So we are working with the country pairs. And then we are not working with the returners. So we are working just to the different flows. And we created 3 disjoint classes: citizenship, birth, and residence. If you remember at the very beginning, I said that measuring the stocks, we usually use the country of birth and nationality, but we also used for the European case, particularly the residence. The residence refers to reason, because you might be residing in a country for different reasons. So we combined these 3 aspects, and we are working with 2019 as our reference point. The integration, we work with the demographic statistics, and then it's the geographical info as of course. We also check prior information, let's say net immigration, the total volume, and we developed new indices from scratch. So as I mentioned, we are working with the social connectedness index. So what it does is, in fact, it gets two locations. So this is a data public, so you can also download it yourself from the Facebook Data for Good webpage. So you have two locations, and then, in fact, it measures the relative probability that two individuals across those two locations are friends. So this creates an index which gives us the idea of the social connectedness between countries. But what we did, we developed an MI, which is a migration index, by getting those two locations. And instead of two people, we get one person, and we calculate the probability of that person to be a permanent resident, okay? Or a person, the probability of that person to migrate from the location I to location J. So yeah, of course, the methodology requires a lot of machine learning behind. So we tried several methods, but at the end, what is important is that with the social connectedness index, friendship is mutual and two-sided. What I mean is that if you add someone as a friend, that friendship is defined both sides. So the indices are pretty wide scaled. It starts from 1 to billion. Let's show you some of the results. So this is just to show you the correlation between the index that was developed by the Facebook and the migration index that we developed. So here we just would like to show that existing correlations can help us about how reliable or how usable our indexes. We are not checking any kind of validity. Okay, so these are really the assessment approaches. So on the left-hand side, you see the change of residence, so migration. And on the right-hand side, we check the citizenship and residence. So we try to check, as I said, 3 different measures. So the correlations are pretty okay. I gotta say that you can also see it on the graphs, because on the right-hand side, you know, like it is the migration flow by the social connected index for the citizenship residence, and the left side, it's the change of residence. So we also checked it very specifically for the birthplace, residence, and citizenship. You do see that the indices are very highly correlated. This just tells us the idea. It's a good start. Please let me underline that we are not claiming yet that our index is any better or in comparison to others. Now we are still working on developing the index and assessing the, let's say, the reliability. And then I'll give you an example. What we did is we just checked, based on the Facebook connections as well, the international citizens moving their residence from one country to the other one. And here we worked with larger geographical areas. We have South America, Asia, and Africa. And what you can see is that on the right corner that I had this red circle, these people are heading to West Europe, okay? And the other group that you see below are the Eastern European ones. So it is already interesting to see that even the comparison or even the correlation between those two indices tells us something, that people, we do see some patterns in also these connections, but also the change of residence. So we also try to see, okay, how it's going to work if we get a country specifically. So we checked Spain because it is one of the main receiving countries in the last years. So we checked the migration flows to and from Spain. So we have the international citizens, which means non-European ones, and then we have the European citizens. You will see that, you know, like we do see Peru, Ecuador, Colombia, Argentina, Peru in in the international citizens, but on the European citizens, we have a lot of Italians, British, Romanians, Belgians, Portugal, and Bulgaria. So these are the calculations by the social connectedness index. So this is the connections of people on Facebook, but but it is very much aligned with the index that we developed to. So what does it tell us? So most of the connected countries that I listed, they don't share migration flows, but we do see that these countries are Spanish colonies. So that brought us to the question that, oh, even though we are working with pure data and trying to understand the patterns in data with the very basic information, we can still make sense of the political and social context. So we wanted to see, okay, let's get an example then and see how the colonies and historical background can help us. But instead of Spain, we got the case of the Netherlands. And what you see on the left-hand side, it's the top 10 countries from Aruba. So the migration from Aruba, the people from Aruba, they mostly go to the Netherlands. You can see the disproportionate, like more than 70K. And then the Belgium, Malta, Portugal, Italy. And you do see that the proportion of the migration index that we developed and the social connectedness index are very, very similar. And then when we put it on a graph, visualization worked even better. You see the Netherlands standing out. So of course, we try to do it for smaller geographical units as well, for the autonomous regions and territories. However, we do not have the social connectedness index for that. Like Islands, and the Faroe Islands, but we we couldn't check it because of the lack of data. So even if we are working with big data, we are talking about some data shortages. And then secondly, what we did, in addition to the estimating or developing an index to estimate the migration stocks, we said, okay, can we go deeper in understanding the highly skilled migration? And for that one, we refer to LinkedIn data or data and the bibliometrics. So we mostly use the Microsoft knowledge gap, knowledge graph. Probably you do know that, MAKG, if I correct it. So we work with several data sources. And what we did is we tried to integrate different data sources to show, can we quantify the highly skilled migration within EU and out of EU? Can we see some drivers? I mean, here, when we say drivers, we are talking about some patterns like the sectors, countries, genders. And of course, we also wanted to see the social network. To give you an example, when we are talking about academic data, and academic collaborations are the social network, when you talk about a gravity theory from the academic migration perspective. So, wait. Oh, okay. So, however, I got to tell you that we have a paper under review right now, and what we do see that we do develop the yearly collaboration index. So we started with LinkedIn, and why I included this slide is that we could not use LinkedIn in the way that we planned, because when you're working with API data and big data, you should also know that the terms of services and the availability of the data changes very rapidly. So we could download some data in 2019 when we started the project, but in 2020, the data that we downloaded was not exactly the same. I don't mean in terms of the users, in terms of the structure and the information that we could extract. So when you are talking about private loan data, it is also a challenge to ensure that the data that you get is the same, or you can get the data at the same time. So in addition to the social data, so this was about the high-skilled migration as well as the population stocks of the immigrants. We also worked with satellite data. I got to tell you that the data preparation of the satellite data has been the most challenging one, because the data is enormous, but it requires a lot of data processing and a lot of ML techniques. So one of our partners who are expert in that, they really worked amazing to develop the relevant indicators for us. So the ultimate goal is to get a case of Somalia, to develop some indicators that are not there already, and to see if we can use those indicators to understand environmentally induced migration. I'm sure you have heard of environmental migrants, environmental refugees everywhere. It's very important to say that when we talk about environmentally induced mobility, human mobility, it's not possible to talk about a unique or a marginal effect, because we are talking about extremely fragile and vulnerable geographies where economic problems come along with security problems, in addition to that, this extreme weather events. So instead of 2005 to 2018, we are working with the 2016 to 2019. We are working with 2 sentinels of the European data. So what we do is that we are not analyzing international migration in this case. We are working on displacement, like especially the internal displaced people. And environmental and climate change is our main focus. So these environmental migrants are defined by UN and UNHCR as the people who left their countries due to sudden or long-term changes to the local environment. And our work package 4 is solely devoted to better understand the environmental displacement in central and southern districts of Somalia. I'll explain you why we chose those areas. And GMV is the country who are one of the main service providers for the European Space Agency. It was the leader, and I had the opportunity to work with them. So why Somalia? Okay, so when you have the reasons of internal displacement, because we always start with the context, you see that in 4 years, okay, in 2016 and 18, conflict was very important, but drought-related or flood-related mobility was at high. What happens is that in Somalia, UNHCR and several humanitarian organizations, they do ask people when they change place, why did you leave your home? And they can say that, oh, the reason could be drought-related, flood-related, other miscellaneous reasons, or the conflict related. So we do see that we are talking about almost millions of people who are internally displaced due to environmental events in Somalia. And then why central and south? Oh, sorry for the typo. So in fact, these are the areas where most of the people live. But also when you see the land covers of the vegetation, these are the areas where we do have the most agricultural activities. I gotta give you the feedback, or let's say the background information about Somalia, is that Somalia is a very pastoral community. So these people, their lives depend highly on agriculture, croplands, crops, and also cattle, because they live with their animals and only the agriculture. So what you see on the right-hand side is, like you'll see that there's a huge overlap between the population density, the vegetation, and the internal displaced people due to environmental issues, that's especially drought is the yellow dots, so and the blue is the floods. So this is the area that we worked with. It's pretty small grids. And you do see these blues, these are the main rivers in Somalia, which is very important for the livelihoods, because that's where people get to water for themselves and for crops and for animals. But on the other hand, when there is an extreme event, these places are where you have the most detrimental floods. Okay. So in fact, we are looking at a pretty large on a very, very small grids. So what we use is that we are combining different indicators. So we developed the Earth observation indicators that you see now, like they do. I'm not going to go into details, but I'm going to show you how we use them rather than how we develop them. We are talking about this vegetation indices, the drought agricultural indicator, flood, land cover. Land cover changes, like, okay, you have a vegetation in an area and how the change differs in years. And then we have the displacement. So we have the IDPs, like internal displaced persons, due to drought, flood, and other reasons. And for the socioeconomic controls, we check the food prices. Maybe I should spend a couple of minutes here that we really wanted to have better socioeconomic indicators to check. However, we are working on a very small grid, as I said. Most of the environmental studies are qualitative, or the quantitative ones are focusing more on not people, but the environment. Or when they do it with people, it's usually on the country level. But here we are talking about district level, which is 100 by 100 meters. even, so which was very difficult to get any kind of statistics on that. So we expanded it. So we aggregated our data to district level, which is the smallest administrative unit in Somalia. But there is no statistics about the socioeconomic indicators in Somalia. So it was pretty difficult. When there are a lot of missings, there are a lot of flows. So the food price was the easiest one. It's really important because it shows a lot about the economic status, but also the impact of the changes in the area. So we use satellite data, we use the European Space Agency and SPI, and then we are using them to develop our reports and the online maps. And then, of course, we are using different data sources by the humanitarian organizations as well as international organizations. And we use UNHCR and World Bank data for socioeconomies and IDPs to show you. So these are our results, like our ADI. You see these colors differences because we believe that our indicators can be used for early warning systems. So which means if we are talking about an area with a lot of rats, these areas are expected to have drought in a very short run. So that is also important for the humanitarian organizations that we can expect these people to move. So we have more detailed ones. The reports are online, so you can check them. But you will see that we are checking the seasonality. So and looking at the SPI, so which has been used a lot, this kind of a drought index, you will see how things change in time and how we compare it with different indices that we did. So we also did it for floods. Okay, so I think when you compare two specific maps, you're going to see that things change. Okay, and the flooded area and internal displaced people are highly correlated. So you do see that in the second one in October, there were more than 200,000 people internally displaced due to floods. So on the left-hand side, you do see that, like on the x-axis, we are talking about different districts. So these are the names from those districts, and you can see the change in time, like in which year what happened. It also gives you an indication of what happened in that district. So I will briefly skip. We also did it for the land cover, which means the vegetation around the river. So we can identify the agricultural field, forest, also settlement or soil or water in general, and we can check the changes for droughts. And we also did it for flood, especially for the agricultural or non-agricultural ones. Now I would like to get your attention to our final results, because this not very good looking graph is the best that we could do to combine the drought and displacement indicators. Very briefly, you see that it's time series, so it's longitudinal. And you do see these bands of yellow and light purple, like lilac. These are the rain seasons in Somalia, so Gu and Deir. So these are the agricultural seasons because people do know that they will get rainfall. When they have too much, there are floods. When they don't have enough, there is drought. So these times are very important for people's decision making because they do know the environment better than any others, and they plan their migration and mobility based on these. So what I would like to get your attention to the green line, which is the net IDP, which means these are the number of people who moved based on droughts. You see that there are a lot of fluctuations, and the black is the total one. You see that in 2017, especially in the first one, as of January till I would say March, April even. So there's a huge spike, which is in fact the drought, because the red line shows you the area. And you might say that, but I don't understand, because the peak in drought was right before the beginning of 2017. So I'm talking about this first lilac pot. So you do see that the drought was top in late months of 2016, but people move first months of 2017 because there is a lag. People, I mean, based on the capabilities approach, we do know that people do need some time and resources to move, to afford the migration. When we see that obvious in drought, because drought has a long-term effect, we also check several qualitative studies where we see that people people can respond differently to the crisis that they're dealing with, especially when it is environment. There are some people saying that when they see the shock, this exogenous shock, they say, oh my God, we have to sell everything. We're going to get our money. We're going to move out of here with our family. So then there were a lot of fluctuations in the goats prices, particularly because when people want to move, they sell, then the prices drop. And or there are some people saying that, oh, we can't afford it. And they waited in their terms till the last goat died. So in fact, the responses are different, the capabilities are different, but we can see it in our graphs. And when we do it flood, it's easy to follow because you will see that we have this the navy and the green lines around 2018 July, because this is the big shock. And what we do, so we combine it with drought, and you do see that when there is a flood, the response is more immediate because of the detrimental effect of that. So people immediately move, but then it goes back to normal. Why this decline? Because there are no people left to move. So in short, we can really talk about different areas. And second thing important to mention is that this, if you recall, this yellow band refers to rainfall, and we are talking about floods. So people know that there would be more floods, so they immediately moved. And it happened also in 2019, because then the number was even higher. We are talking about more than 60,000 people internally moved. So in short, our indicators work perfectly well to explain this internal displacements, yet we do know that our models are not elaborate enough to talk about other factors. We did check it for some conflicts, like in the area, because most of the time they're overlapping. We also checked the food prices, but I think the better data is needed on a more granular and more for smaller area, because the data, the statistics are annual, but you do see that in 1 year a lot of things can happen, and we are missing the variance in that. So I talked about the social media and then the satellite media, and my final illustration will be about the mobile phone data. So I gotta say that the mobile phone data assessment is possible because we also work very closely with Turkcell as a partner. But I will talk about these ethical measures that we took at the very end. So now, what type of data we are working with? Aggregate level, anonymized data. So it's not possible to track anyone. So we do have 4 data sets. The first one is the antenna location, which means when you have your mobile, so it is connected to a cell close to you. And then we have the timestamp, we have the site ID, we have the number of signals. It's important to tell you that we are not talking about tracking any single number. We are talking about aggregate signals in an area, and we tell specifically where that signal is, but we are talking about a larger geographical area. The second data set we are working with is a fine-grained location data set. In this case, we do have a day, an hour, we have the district, the city, and for the customer ID, we have anonymized numbers. So in this case, why we did it, I'll explain it more, but we divided the day into different areas. And the third one is coarse-grained. So now we are talking about the segment of the user, because it's really important for the segment is that we are talking about some specific backgrounds, aggregate levels, that we do know if that person bought the number with a passport from Middle East, from East European, but we are talking about broad areas. Though for Afghans, we got them as different categories. And then we also have, of course, these people are the ones who lose signal in Turkey, and we do not see them for the next 6 months. So we do assume that these people leave the country. So regarding the ethics part, it's important to tell you that we do not have the data. The data stays at the company, but we are working with FlowMinder and an Opal system. Opal system refers to open algorithm systems. It was developed by Datapop Alliance. It was an MIT and Stanford initiative. So very basically, it's a kind of federated learning system. So there is an extra server at the Turkcell where the data is stored. We can run authorized queries on the data and we get the insights. And all the anonymization has been done according to, of course, before that. So in fact, the potential users and developers know the structure of the data, but not the content of the data. And so everything is an open source, and which might be interesting to show you that. So we did some basic descriptions. So for the Syrians, especially male Syrians, you see that distribution of the population by quintiles, by province. And we also calculated the migrant diversity based on Alesina's work. So we have to say that there is a bias that we couldn't deal with yet, because we do know that when people buy their phone numbers, there is no guarantee that the registered customer is the one who's using that, which means, and which is also showed by some qualitative studies in Istanbul, that Syrian women, tend to have their numbers registered to either husband, brother, or their son. So we are missing the women, and this is a kind of overestimation. Secondly, we do not have the minors. So there are plenty of children, we do know that, let's say above 15, they have mobiles, but we can't know and talk about them because the customers should be above 18. So this is a bias, but it's a proxy. And the migration diversity is calculated with a very well-known index. So what we did, in fact, we are currently working on a paper which is under review. This paper might, at least the topic might be very familiar to the audience from Turkey, because if you do remember, in 2020, in 28th of February, if I'm not wrong, the president of Turkey, Recep Tayyip Erdogan, made a statement, a political statement, saying that, okay, now we are opening the gates. And the political background was about this disagreement, what was going on in Idlib then. And then when you follow up the political statements by different ministers and President Erdogan, it was saying that more than 40,000 cross the border. We are going to allow all the Syrians go to the Europe. So this political rhetoric became kind of a threat on the EU-Turkey relations. And by then, what we said, oh, it's interesting. Can we really see how many people left? And who are these people? So we started to immediately gather data from different data sources. We have Twitter data. So we collected a lot of tweets. And then we collected the mobile phone data. And what you see on the right-hand side is, in fact, the Greek and Bulgarian border. Very dark purple part is the Greek border. So based on the Turkcell data, we prepared, as you see, they are really aggregates. And we are talking about total number of customers at that area. And then on the left-hand side, these are the number of customers whose signals left, and we couldn't see them for the next 6 months. As you see, we are talking about maybe 14,000 people. I mean, I did not include it here, but the mobile phone data could give us an insight about the numbers who really left. But more importantly, when we combine it with Twitter data, where we analyze the language of tweets, we could see that, roughly speaking, among the people who were at the border, on the border rush, only 20% were Syrians, around 30% were Afghans. We had 20% Turkish people who were at the border trying to leave Turkey because of the opening of the gates. Of course, this didn't take very long time. EU and Turkey had a deal, but in fact, we could see that first. I mean, the main purpose of this paper is is to show which type of alternative data can work better. And we saw that not the Twitter data, but mobile phone data is a better indicator to understand this mobility, especially in urges. Secondly, we can see what we cannot do with it. So that was an iteration of our paper, and what we are currently doing is that we do not have all the results yet. We are working with the call data records for Istanbul. So it's for 2 years, almost a year for sure, but we are working on the ethics and OPOL, as I explained. So we are working all the personal information, and we do have an ethical committee of the Hummingbird, and we are working on the aggregation and anonymization based on the prior studies like data for development, data for refugees. And what is to come that we haven't done yet is we are going to combine also CDR, the mobile phone data, and night lights, because what we do with the antenna traffic data, we divided the day into three. We have the night, we have the day, we have the evening. So we assume that people spend their day with their occupations. It could be a study, they could be students, they can work. So that's good. That will give us the idea of where these people work. And the night is an indicator for residence. So why we would like to combine it with night lights? Because in the Turkish case, we do know that very few of the Syrians are really, or let's say the refugees in general, are registered officially. So based on the statistics of at least, let's say, the work permits, we are talking about only dozens of thousands when we have almost 5 million people. So we would like to see where they live, and especially in non-residential areas. But we are very careful, and we are really working on now with several social scientists and data scientists to see how we can assure that this information will not be used against them. Because here our idea is to give some insights about the need for services, like if they need a public transport in that area, or if it's not a residential area, maybe they need healthcare, they need water, they need sanitary. So it's really important to know where these people are to bring them the services. But on the other hand, it's very challenging, especially in the political framework. So when we work with big data for migration, the challenges are doubled, because the migrants and migration are also very vulnerable groups. So there are biases in the data or the machine learning algorithms, because we the humans are biased. Data protection and privacy rights are very tricky, because the data sets, these could be the social media, as I said, videos, photos, or it could be also online platforms. These could have also the mobile phones. These could have personal information, and we have to make sure that data protection and privacy rights are compliant. And then the explainability and auditability is very important, because we need to be very clear with what we are doing with data, how we are doing it, and that it could be kind of audited, so that the it could be explained, everything is open. So yet it's a challenge, because any information relating to an identified or identifiable natural person, these are migrants. So we know a lot, especially if you are talking about the refugee center. I think Emre Hoca yesterday talked a lot about these digital identities and blockchain. So we know more than we have to know about them, regardless of the big data, like all the data kept. So here I would like to underline the processor, which means, like data provider or data owner is different than the analyzer, because we also have the processor. So it's really important that the responsibilities are for everyone, not only for the others. So I think I'm on time. So thank you very much. And thanks for the patience if I pass a little bit more than I have to.
Hocam, thank you very much. I think this has been very inspiring. Are there any questions for Tuba Hoca? If not, I have several. All right. In the meantime, I think I can start with one.
Please.
Now that, Hocam, you are using a data-driven approach, right? When you're using a theory-driven approach, you know what kind of data to look at, right? There are 5 or 6 that they are already determined. But when you're using data-driven approach, there are hundreds of thousands of data types, like in terms of context. Isn't it very time and energy consuming to determine which data to look at? Or how do you decide to use which data to make which indicator?
Yeah, very, very difficult question to answer. I gotta say, I don't have a short answer, but I can tell you that I think when we are talking about data-driven approach with big data, in fact, we are not talking about the models. As if you realize or notice that, I'm talking about data-driven approach to derive indicators. But in fact, what I didn't present today is that we are trying to see how we can integrate these indices into our theoretical models. Like, in fact, what we try to do is we are trying to model the migration flows with traditional data, with econometric models, very well-known things. And what we do is that we also know that several migration theories talk about, I mean, take the gravity model, okay? So we are talking about economic power and on the imbalance to understand the flow of migrants from one country to the other one. But we also know that networks are the meso-level drivers, which means it is also part of the gravity model. Like, it's not only about how poor your country is and you are heading to a rich country, but it also matters if you have a network there. In addition to that, what are the other potential drivers that we can explain? When I say drivers, I'm honestly talking about this in economic models, the exogenous variables. So there, our idea was that, okay, we are working with data in terms of stocks, but our data is old because we are working with old data. So can we have an index that is going to nowcast what's going on today so we can include it into model? And so the theoretical approach is also time consuming in a way that making sure that you measure the thing that you want to. And it has been studied a lot, and we are trying to go beyond that. So when we are talking about climate migration, if you have a model, which variable you should include for that? Is it the temperature? Is it the exportation participation rate? So we don't know. So I guess the time really for deriving to see if they work in a model or not will be our theoretical part, already saying what is not working in the existing models, or to look for potential areas. And with different ones, with social media data, it has not been used a lot. But there are other studies. To give you an example, like Böhme in 2020, he published a paper about can we use Google search data as an aspiration index? Because assume that from Turkey, a lot of people are asking for like golden visa, migration, also the asylum, family unification, getting a job, work permit in Belgium. So then this aggregate level data, they included it into their models, regular economic models, and it improved the model. So in fact, rather than doing everything from scratch, we are talking about combining things. So if we know what we lack, then it might give us a starting point to see where can we get that data. So of course, it's not very straightforward, and it's really an emerging area. But I think the more studies there are, the more indices will be developed, and they will be all public. For the hummingbird case, I mean, this is the end of second year, so we have 2 more years. And at the end of 2 years, we will make all data publicly available. So all the indices. So there are others that I didn't mention. For instance, with the social media data, we developed not 3-level migrant friendliness index, just based on the topic modeling and sentiment analysis, saying that who talks nicely about migrants or who talks badly, negatively about migrants. So I guess it is more about understanding the area. And I gotta say that our challenge to the social scientists. So we gotta get involved more to really follow up what's going on. But yeah, I know it's not a straightforward answer, but we have the starting points, and I think we should focus on our interest at the time and see what can be the potential sources to make it better.
I see, Hocam. Thank you. Are there any questions from the audience? Or I still have more?
Please go ahead.
Okay. Is one part of your research include a prediction for the potential migrant outflows or inflows?
Oh, so predicting it, like that's the second step. The first step is really developing the indices. And maybe I didn't make it very clear, but we have two approaches. On one hand, we are trying to develop predictors. Okay, like what we do with the social with satellite data, for instance, it's trying to develop predictors. But when we are talking about the prediction models, we rely on the existing theoretical frameworks and the existing models. So we are not trying to improve the models. We are more working on how we can really develop, like have new indicators. And regarding this null stocking, I think there is a study again from our team, from Jisoo Kim. Now she's at Max Planck. I mean, her PhD is all about can we no stock migrants with Twitter data? And she developed the stocks, and then she used the developed indices as the dependent variables. So what we do is not really developing new prediction methods, I gotta say, but so in terms of the flows, we are working on the predictors or dependent variables development so far. I gotta say that there are more studies on the prediction, especially with COVID, but these are more than internal mobility rather than international migration. Because in Estonia, in Italy, and in many European countries, the governments work with the mobile phone operators to estimate the mobility, like where people go. Because of the COVID, we had this lockdown. So they can also use these neural networks to really understand where they're going to go next. But what we do so far is not really in the prediction models.
I understand, Hocam. If there are no other questions, thank you very much, Hocam. Thank you
very
for
welcome.
Again sparing your time.
Okay.
In a Sunday morning.
No, it's okay. I'm pretty happy. So, but I mean, I'll give you the slides. So, I mean, my email is there. So, for any further questions, you can always drop me an email. So, I'll be happy to discuss with the social scientists in particular, like who are interested in what we can do more. Thank you for inviting. It's a pleasure. It's a pleasure to be here.
And thank you, and we congratulate your upcoming paper with Eren Hoca, I think.
Yeah, it's the book. Yes, yeah. Our book is coming. Yeah, it's a book. It's a handbook on data science for migration and mobility studies. It's coming in the first spring 22. So, thanks a lot.
I see. We're looking forward to it. Thank you, Hocam. Have a good Sunday.